Hello everyone, Tom from everystepcalculus.com, everystepphysics.com. We're going to do a Green's theory problem, and with regard to an ellipse. Let's do it. Index 8 to get to my menu. Scroll down to Green's theorem. You can use second and the cursor here to go on your calculator to get there quicker. Here's Green's theorem now. And we're going to enter our usual ellipse function, which they always give you in a problem. And we have to press alpha before we enter anything in these entry lines here. So it's alpha minus y and then alpha x. I always show you what you've entered. You can change it if you want. I say it's okay. We're using the MN system. There's a PQ system also, depending upon your pathetic professor and or any book you're looking at. M, partial of m divided by the partial of y is minus 1. Partial of n divided by a partial of x is 1. We subtract m from n partials and we get 2. And that's what we're going to, that's the integrand now. We're going to integrate with that in Green's theorem. We need to choose what's happening. Here's the ellipse. I'm going to choose number 7. And here's what I was talking about, the 2's in the integral. But the 2 constants come out of the integral. So here's the 2 on the outside times the 1/2, and that equals 1. So we have 1 and then the dA. That's the usual system for Green's theorem. Make sure you write that on your paper. There is an equation given, and this is alpha x squared divided by the quantity 19 squared plus y squared divided by the 6 squared equal to 1. This is already in the ellipse format, but I'm going to divide it by 1 and show you what happens in case that was a different number. If this was some other number, you'd divide the whole, you got to make this 1 to make it in the proper ellipse equation, okay? I'll show you that in a second. Here's the proper form. Here's the answers here. 6 and 19 is the squares A and B. And we're going to change the parameter now, and x equals a times cosine of t, and y equals b times sine of t. We're going to change to the t parameter. And when we use the derivative of x after changing the parameter, is that derivative of y is 6 cosine of t. And here's the formula for the line integral. I'm going to substitute the parameters, etc., etc. I'm going to multiply them together. We're going to add them. And of course, when you factor out the 114 from both the x sine t squared plus cosine t squared is a identity of 1. And we're going to do it over the range. We integrate 1 with respect to t, which becomes t over the 2 pi and 0 range. At t equals 2 pi, 57 times 2 pi equals 14 pi. 0, 0, we subtract the upper minus the lower. Or, yes, subtract the lower minus the upper. No, the upper minus the lower, that's correct. And we get the area of 114 pi. Pretty neat, huh? Everystepcalculus.com. Go to my site, buy my programs, and pass your calculus tests and physics tests step by step with solutions, okay? Have a good one.